Okay, day one of matrices. This is something we're going to look at. It's a good topic to learn because it's something that you will see on your SATs, your ACTs. So first, to talk about what a matrix is. A matrix is a rectangular array of numbers used to solve linear systems. Matrices have dimensions m by n, where m is the number of rows and n is the number of columns. When a matrix has the same number of rows and columns, it's called a square matrix. An element of a matrix is a term in a specific spot. The diagram on the right shows how an element can be located. Okay, so when you see this, like it looks like here, like A sub 11, that really means matrix A, and it's row 1, column 1. So the first digit is what row you're in. The second digit is what column you're in. So for instance, like if I was looking in example 1 at letter A here, A1, 2, looks like A sub 12. A1, 2 means in matrix A, row 1, now rows you go across, columns you go down. So row 1, column 2 would be 4. So the element in row 1, column 2 is 4. B22 means in matrix B, you're going to go row 2, column 2. So across the rows, down the column, that would be a -3. C31 means matrix C, row 1, 2, 3. There's only one column, so that's 3. And B1, 3 is, now we're going back to matrix B, row 1, column 1, 2, 3 is 5. And then D3, 2, matrix D, row 1, 2, 3, column 1, 2, which is 8. Okay. Give the dimensions of each matrix from example 1. Okay, so dimensions of matrix A. The way we would write it is, so matrix A has 2 rows and 2 columns. So we would say it has dimensions 2 by 2. So 2, like a little X, like kind of like your old school multiplication sign, and then 2. Dimensions of matrix B would be, that is 2 rows, 3 columns, so it's a 2 by 3. Dimensions of matrix C would be, so 1, 2, 3, 4 rows by 1 column. And then dimensions of matrix D would be, we got 1, 2, 3 rows, 1, 2, 3 columns, 3 by 3. A system of equations can be written as what's called an augmented matrix. For example, so in the augmented matrix, what you'll notice is they only take the coefficients. So we got a -4x, they just take the -4. We have a 1y, they just take the 1. Equals 3, they just put the 3. And then -1's the coefficient of the x, 2 is the coefficient of the y, and 0 is the other side of the equal sign. Now, a lot of times with matrices, what you'll notice is they'll draw a line that shows, so like on SATs and ACTs, sometimes a line will be drawn there. That'll let you know what's on the right-hand side of the line is the other side of the equal sign. So this is actually what the same thing I just did. So if I wanted to write this as an augmented matrix, I would say negative 4, 1, 3, negative 1, 2, 0. And like I said, or you could do it like that. You could draw a line that designates that the 3 and the 0 are on the other side of the equal sign. Now, if this is the augmented matrix, and we want to now write it as a linear system. Again, if you want to like throw a line in there so that you know the 4, 5, negative 2 are on the other side of the equal sign, you can do that. So then the first is the X, then the Y, then the Z. So generally with matrices, they'll often start like X for the first column, Y, Z. If they run out of letters, they then usually will go backwards to W. So it kind of seems weird, why not just start with W? But a lot of times they'll go X, Y, Z, W. But you just pay attention to the way the system of equations is written. Like if the X is first and then a Y and then a Z and then a W, then that's the order you just put your matrix in generally. And then equals 4, and then the next row, if you go across the next row, there's no X's, 1 Y, 3 Z's, and then equals 5. So Y plus 3Z equals 5. And then here, 2 X's, 1 Y, or 5 Y's, sorry, 2 X's, 5 Y's, 2X, 5Y, 1Z equals negative 2. So that's the system of equation that augmented matrix represents. All right, now adding and subtracting matrices is actually very easy. You could do this on your calculator, but I wouldn't even waste the time entering in the calculator unless I wanted to check myself. But adding and subtracting matrices is easy. So if I want to do matrix A plus matrix B, you are just going to add the ones in the like position. So you're going to add row 1, column 1 with row 1, column 1. So for the sake of your notes, I'm going to show the work here. I'd be doing negative 1 plus 1. Then I would take row 1, column 2 with row 1, column 2, 3 plus 3. And then I would do row 1, column 3 with row 1, column 3, 8 plus 5. And it goes in the same, like, I did row 1, column 3, so that's why I'm putting the 8 plus 5 over here by row 1, column 3. And then I do the same thing with the second row, 4 plus 2, 2 plus negative 3, and 5 plus a negative 7. So my answer then is 0, right? Negative 1 plus 1 is 0. 3 plus 3 is 6. 8 plus 5 is 13. Then 6, negative 1, negative 2. And that's your answer. So this matrix, matrices are written with a hard bracket. So this right here is our answer, that matrix. Okay. Now, A minus B, same thing. You're going to take matrix A, subtract matrix B. Same position. So this will be 3 minus 3. This will be 8 minus 5. 4 minus 2, 2 minus a negative 3, and 5 minus a negative 7. Negative 2, 0, 3, 2, 5, 12. So that's the answer to matrix A minus matrix B. If it was matrix B minus matrix A, then you would just need to subtract in that order. You'd have to start with matrix B and then go to matrix A. Now, scalar multiplication, that's also another easy one. Scalar multiplication is you multiply a matrix by a constant. So just a number without a variable. So like this says find 3A. 3A just means to take everything in matrix A and multiply it by 3. So I would take -1 times 3, get -3. Just gonna make that a little bigger. 3 times 3, get 9. 8 times 3, 24. 4 times 3, 12. 2 times 3, 6. 5 times 3, 15. That's my answer. 2B minus 4A. I take matrix B. So first I'm going to take matrix B and multiply everything by 2. That'll be doing, so this is going to be my 2B, and then I'm going to have minus, and then I'm going to do 4A. Okay, so for 2B, I'm going to take everything in matrix B and multiply by 2. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10, 2 times 2, 4, -6, -14. Okay, then I'm going to take matrix A, multiply everything in matrix A by 4. So -4. 3 times 4, 12. 8 times 4, 32. 4 times 4, 16. 2 times 4, 8. And 5 times 4, 20. And now it's just a subtraction, just like you were doing in the last one. And I'm not going to bother. I'm just going to go right to the answer. So here I would go 2 minus -4. 2 minus a -4 is a +6. 6 minus 12 is -6. 10 minus 32 is a -22. 4 minus 16 is -12. -6 minus 8 is a -14. And -14 minus 20 is a -34. So that is my answer. Okay. Last thing we have to talk about is determinants. So determinants are used to test if a matrix has an inverse. Determinant of A is written as DET of A, and it looks like some bars, they look like absolute value bars. They're not absolute value bars, so don't think like you just take the positive or anything like that. It's just the way it's notated. Determinants are notated with like bars rather than the brackets. So when you see bars, that means you're taking a determinant of a matrix. If the determinant is 0, the matrix does not have an inverse. A, B, C, and D are 4 real numbers. The symbol D equals, and again, these bars, A, B, C, D, is called a 2 by 2 determinant. And so again, if they use the bars, it's a determinant. Its value is the number. Okay, so here's how you do the determinant of a 2 by 2. AD minus BC. So you basically multiply along what they call the main diagonal. The main diagonal is the diagonal from the upper left to the lower right. So you'll often hear me say main diagonal minus other diagonal. So the main diagonal is the AD minus the other diagonal product is BC. So if I were finding the determinant of 3A, I would be doing 3 times 1 minus 6 times the -2. 3 plus 12, right? Minus is a plus, and I would get 15. Or I could write 3 minus -12 and then go to 15. Either way is fine. And last one, okay, main diagonal would be x squared minus other diagonal is 20 because 5 times 4. I don't know if I should maybe show that. We're doing 5 times 4. And then equals the other side is 5. X squared minus 20 equals 5. X squared is 25. X is then plus or minus 5. So remember, this is where when you square root in an equation, you have to have the plus minus. So remember, I know at least in one of our classes last unit, we talked about like, if I just ask you what's radical 25, the answer is just 5, not plus or minus 5. But if I say x squared equals 25 and it's an equation, and now you have to square root, then you have to say x equals plus or minus 5. So in something like this, you would have to say the plus or minus 5. Oh, and this should, you know what, this should not have said find the determinant. This should have said solve for x. Because we know the determinant. The determinant is the 5, right? That's the answer. But what they wanted there, it should have said solve for x in that case. Okay, that's it for day 1. Just make sure you do the day 1 homework, which is out of the book. Tomorrow we will be, this Friday, we will be live in class doing some calculator stuff with matrices. All right, have a good day.